All right, these are practice problems for the logarithm test. I suggest you hit pause on each problem and see if you can get it correct. All right, for this problem here, they want us to find the compound amount. All right, that is basically the accumulation. So this is 10 grand invested for 8 years, earning 7 1/4% annual interest, compounded weekly. So A is the accumulated amount or the compounded amount. P is the principal invested. So we can see that this 10 grand is going to equal P. Okay, T is the time for the investment. So the 8 years is going to be your time T. R is the interest rate. Okay, so we're going to have to convert that because it is 7 1/4%, which is 7.25%. You want to convert that to a decimal. All right, so you need to move the decimal place to the left 2 places, and that makes the interest rate 0.0725. Okay, and finally, N is the number of times it is compounded. If it's compounded weekly and the interest rate was given yearly or annually, how many weeks are in 1 year? That's 52. All right, so if something is compounded weekly, it is going to be 52 times per year. All right, if it were quarterly, that would be 4. If it were monthly, that would be 12, but weekly, that's 52. All right, now we're just letting the formula do the work. The accumulated amount A is the principal P, that's 10 grand. And that's times 1 plus R, where R is 0.0725. Divided by N, that's the number of compounds we said is 52. Usually it's the number of times per year. All right, again, N we said was 52. And that is times T. We said T was 8 years, so the exponent is actually 52 times 8. Okay, so what I do on this, I evaluate this in parentheses first on the calculator, and then do that to the power of 52 times 8, then take that answer and multiply it by 10 grand, and round to the nearest cent. 2 decimal places. All right, I get 17,853 and 17 cents. Make sure your answer makes sense. If you start with 10 grand and you earn all that interest weekly for 8 years, that does make sense. All right, hit pause. Hit pause and try this one here. Okay, you're going to use this formula again, but in this case, they're looking for the present value, so you want to solve for P. All right, this is really the same formula, but we're working backwards. The present value is what we are looking for. That is P. The present value would be the principal amount that you invest. And 20 grand is what you end up with. That's what you accumulate after that investment. The time T is 8.5 years. Okay, I would just use 8.5 for the time T. Okay, and 6% annual interest. You have to move the decimal over 2 places, so 6% becomes 0.06. And finally, compounded monthly. How many months are in a year? Well, that's just 12. All right, so let's see the accumulated amount. This is the amount that you end up with. That's 20 grand or $20,000. And that equals P, the principal or present value, same thing. That's going to be times 1 plus R, which is 0.06, divided by N, which is 12. And that whole thing is raised to the power of N, which is 12. times t, which is 8.5. All right. So finally, solving for p, we are just going to divide by this whole thing right here. All right. We're just dividing by the same thing because p is multiplied by this whole thing. And the opposite of multiplying by that is dividing by that. So 1 plus 0.06 divided by 12 to the power of 12 times 8.5. All right, on the right-hand side, the same thing over itself just cancels. And we're left with p, and I'm going to do this on the calculator. I'm going to do the denominator first. Use parentheses, 1 plus 0.06 divided by 12, and that is to the power of 12 times 8.5. All right, in the denominator, I got about 1.66. I did 20,000 divided by that answer. And rounding off to the nearest cent, I got 12,025 and 18 cents. That is your present value or your principal amount, same thing, that you would have to invest at that rate for that time and get $20,000. Now, if you had done this algebraically, you can do the algebra first before you plug in the numbers. You would divide both sides by this right here, and this would be in the denominator right here. And if you take something in the denominator and move it to the numerator, just change the plus minus sign on the exponent. So you could theoretically say that P equals A times this right here, 1 plus r over n, and the exponent is now negative nt. Okay, because this right here would be in the denominator of a. See, we divided both sides by that. So the exponent would be negative if you had solved for p algebraically instead of plugging in the numbers first. But it's the same thing. All right, please pause and try this one right here. They want you to rewrite the logarithmic equation as an exponential equation. So please try it. Okay, the base number right here on the log is a 3. So since this base is a 3, you want to make this the exponent on the number 3. Okay, because now this is the base of 3 as well. And if you do it on the left, you want to do it on the right-hand side as well. All right, if this base matches the base of the log, those cancel, and you're just left with the 9. And on the right-hand side, you have 3 squared. That's it. Does 9 equal 3 squared? Yes, indeed. All right, so that is an exponential equation instead of the log equation. All right, try this one. Same thing. All right, the base number is a 2. So you want this base to be a 2 as well. Whatever you do to the left, you want to do that to the right. The 2 and the log base 2 cancel. You are left with the argument of 1/8. And that equals 2 to the negative 3. And that's actually true. 2 to the third is 8, but 2 to the negative 3 is the reciprocal, which is 1/8. So that works. All right, try this one, please. Convert this exponential equation to a logarithmic equation. So it's the other way around of what we just did. All right, you see the base right here is an A. So the base on the log is also going to be an A. I'm going to take the log of both sides. All right, so I'm going to do log base A of A to the third. All right, you can use parentheses if you want. And log base A of 4. All right, so I just did the same thing to both sides. And now the base of the log and this base cancel. And you are just left with the 3. So log base A of 4 equals 3. That's it. All right, try these 3, please. They're very simple. Just evaluate each one. Tell me what they equal. All right, ln of e to the 15th. You don't even have to write all this, but just remember that ln is actually the same as log base e. And that's log base e of e to the 15th. All right, we just said if the base of the log matches the base, they cancel, and you are just left with 15. Okay, same thing on the other ones. E is just a number e. ln of 14, that's really the same as log base e of 14. Okay, this base e matches this base of the log, which is also e. They cancel, and you are just left with 14. Simple. Okay, and the third one is the same as the first one. The natural log of e to the negative 4. Natural log of e cancels, and you are just left with the exponent of negative 4. All right, try this one here. Solve for x. And it's the same thing as converting to an exponential equation. So you see the base here is 3. So work with that. All right, the base is 3, so I'm going to make this the exponent on the number 3. Other side, same thing. The exponent on the number 3 is 4. This base matches this base, so these are gone. They cancel, and you're left with the x plus 1. 3 to the 4th, 3 multiplied 4 times. That's an 81. Solving for x, if you do minus 1 on each side, x is just 80. Simple. All right, try this one here. Find the domain and give your answer in interval notation. You want to remember that the argument that you're taking the log of has to be greater than 0. All right, log base 5, it doesn't matter the base on the log. The argument, the thing you're taking the log of, must be greater than 0. All right, so 2 minus x is greater than 0. And I'll do plus x on both sides. X is canceled. 0 plus x is just x. And basically, x is less than, the arrow is pointing to the x, so x is less than 2. Let me clean that up. All right, add x on both sides. It cancels here. And 2 is greater than x. In other words, x is less than 2. On a number line, if you started at 2, you would basically not include the 2 because it's not equals, and it's everything less than 2. So that travels to negative infinity. In interval notation, you start at negative infinity and you run all the way to 2. It does not include the 2, so you use the rounded parenthesis. Infinity is never included, so you use the rounded parenthesis. If it did include 2, you would use the square bracket like so if it included 2, but it doesn't. So that's it right there. All right, here we want to rewrite this as a single logarithm. So let's see. We're going to have to combine all the rules. And generally, when you rewrite as a single logarithm, you want to do the power rule first. Okay, so we can see the argument on all of these logs. The argument on this log is 4x. The argument on this log is a 3. And the argument on this log is a y. All right, so let's use the power rule first. The exponent can go from here to the coefficient out front. It can also go the other way. So the 3 is going to be the exponent on that argument. So this 3 is gone. The positive 2 is going to be the exponent on that 3. And leave the negative sign here. The 2 is going to be the exponent on that y. All right. You don't have to rewrite. I'll just do it so it's cleaner. We have log of 4x to the third plus the log of 3 squared, but we know that 3 squared is just 9, minus the log of y squared. All right, so remember, log of a plus log of b is the same as log of a times b. So combining these two, where we are adding, we're going to get the log of, actually I missed this step, let me fix that. All right, this here we want to combine, see I did the 3 squared is 9, I want to simplify 4x to the third. All right, I'll do that off to the side. 4x to the power of 3, that exponent gets applied to both the 4 and the x. Okay, so that's equivalent to 4 to the third times x to the third. And 4 to the third is actually 64. X to the third, we leave that alone. So 4x to the third is equivalent to 64x to the third. All right, so this is, let me just write it here because I had it here already. All right, so now we're in business here. We're going to use the product rule because these are added. What's going to happen is we rewrite the log. Since these two logs are added and the bases both match, they're both base 10, we're going to multiply 64x to the third times 9. All right, so that's going to be 64 x to the third times 9. And that's minus log of y squared. Okay, let's see, multiplying this, there's no x here, so it's x to the third, and 64 times 9 is 576. So we basically have the log of 576 x to the third. And right here we are using the quotient rule. Since it's minus, it's going to be this divided by that right there. So we have the log, and that's divided by y squared. That's it right there. I should really extend these parentheses because it's the log of this whole thing right here. All right, so when it asks you to do it, write it as one log, do the exponents first. And if you have the exponent outside the parentheses like here, you want to distribute that exponent to each term. All right, on this one here, they wanted us to expand. They wanted us to go the other way, so please try it. And remember, when you have a square root with no root here, the root number is automatically a 2. Okay, so please try it. All right, we have the log. And the exponent on this whole thing is 1/2. Remember, when it's a square root, the exponent is just 1/2. So that's 2y to the third divided by x. And the exponent on that is actually 1/2 because it's a square root. All right, so it's a square root of this right here. And now first, let's use the power rule, the exponent rule. Let's get rid of this. That goes out front. All right, so we have 1/2 log of this right here without the exponent. 2y to the third divided by x. All right, so we keep the 1/2. And we're going to break up this log here. Keep the 1/2. We're going to break this up. Right here we have the log of 2 times y to the third. So we're going to use the product rule. Okay, log of 2 times y to the third. Remember that the log of a times b is log a plus log b. All right, so a times b, it's going to be the log. We're going from this to this right here. We're trying to break it up. So it's the log of 2 plus the log of y to the third. And when you're dividing by x, you're subtracting. Remember, log of a over b is log of a minus log of b. Okay, so this divided by this, it gets subtracted, so it's minus log of x. All right, that is log of x. All right, if you wanted to do one more step, you can take this 3 and move it out front. So just remove this 3 and move it to the front, and it would be plus 3 log of y. Okay, so you can rewrite this as 3 log of y. And really, that would be it right there. The only other thing you can do is distribute the 1/2. The 1/2 would be in front of this. 1/2 times 3 is 3 halves in front of that. And 1/2, it will be a negative 1/2 there if you needed to distribute it. But that's it right there. All right, so right here, they want us to solve for x and give your solutions accurate to 4 decimal places. All right, so this problem here, please pause and try it. So you can use log or natural log on both sides, but I think the simplest thing to do is, since we have a base of 15, is to use log base 15. All right, so I'm going to do log base 15 on both sides. So that's 15 to the 3x minus 2. And on the other side, we have log base 15 of 10. All right, on the left-hand side, log base 15 and 15 cancel, and you're left with the exponent, 3x minus 2. And here we're going to use change of base formula. Okay, remember the base is always on the bottom. So when we do the change of base formula, you use log, or you can use natural log. As long as it's the same on the numerator and denominator, you're okay. All right, and the base goes on the bottom. That's how I remember it, base bottom. So that number is on the bottom, and that leaves the 10 to go on the top, or the numerator. All right, and that's the toughest part. Solving for x, the opposite of minus 2 is plus 2. Do that to both sides, and here we have x times 3. The opposite of times 3 is divided by 3. You divide this whole thing by 3. So the 3's cancel, and x is this right here. Okay, if your multiple choices are in this form, you're done. Otherwise, they said 4 decimals. Let me do this on the calculator. So x is approximately 0.9501. Okay, if you want to check your answer, just plug it into the original. Now, like I said, if you had done log or natural log on both sides, that's fine. You would have had to use the exponent or power rule, and this exponent would have been moved out front in front of the log. But it's the same thing. And right here, if you had regular log or natural log, you still would have gotten the same answer. So if it's multiple choice and this says ln instead of log, that's perfectly fine. All right, please try this one here, and we're still using the same investment formula for compound interest. So they are asking, how long will it take? So we are clearly solving for a time t. And the investment is going to double. Okay, That means if you invest P, remember P is the amount invested, that you're going to end up getting an accumulation of 2 times P. So if the investment is going to double, the end result for the accumulation is going to be 2 times P, all right? Because the investment is just P. All right, 6.5% annual interest. Well, of course, 6.5% converted, move the decimal over 2 places. That is 0.065. Okay, so that's your interest rate, R. And compounded daily. Well, how many times is that in 1 year? Well, daily is number of days in a year. That's 365. So the number of compounding periods, N, is 365. All right. So we have everything we need, okay? And I should have wrote the 2P gets plugged in for the A, not the P. All right, anyhow, we want the investment to double. P is what we invest, and we want to end up with 2 times that. So 2 times P, and that equals P. Okay, we don't have an actual investment amount. Times the quantity of 1 plus the rate, 0.065. Divided by N, which is 365. Times N, again, which is 365. Times T, which we do not know. So this is 365 T, 365 times T. All right, we're trying to isolate the exponent. We want to take the log of this, but the P is in the way. We have a P on both sides, so let's just divide both sides by P. Cancels on the left, cancels on the right as well. P divided by P. All right, we have this right here. We can do log or natural log. Either one works. I'm going to do natural log this time because I want this exponent to move out front with the power rule. Okay, if we do natural log here, you want to do natural log here. So we have ln of 2, and leave some space here. We're going to do ln of 1 plus 0.065 divided by 365. And the exponent here is 365t. All right, power rule, exponent rule, either one. I'll do it in a different color. All right, when you have the log of something with an exponent, you can take that exponent and move it to the front, so that is 365t. Okay, and that is times, this cancels here, that is times this whole thing right here. All right, so this is 365 times t times this. So we're in business. Solving for t, t is times all this, so we're just going to divide by all that. Okay, so we're going to divide by the 365 times ln of 1 plus 0.065 over 365. All right, and same thing on the other side, ln of 2 divided by 365 times ln of 1 plus 0.065 over 365. Close parentheses, close the brackets. Okay, on the right-hand side, what happens? It cancels. 365 cancels. This mess over itself cancels. We are left with t equals. All right, this is the equal sign here. We're left with t equals, and we're going to have to round off, but I'm going to do all this in the calculator. If you want to do the bottom denominator first, do that, and then do ln of 2 divided by that answer. And I get 10.66 rounded off. What are the units? Well, the interest rate was in years. It was an annual interest rate, and remember, the units have to match. So that is going to be in years. How long will it take? is in years, 10.66. All right, here we have a half-life problem, and it has an annual decay. All right, so since this is a population decay, you are going to use A equals PERT, but the RT is a negative exponent because it's a decay. Now, this is for investments or banking, but it's really the same thing. And if you want to use the official population formula, it's N of T equals N sub 0 e to the negative RT. These are both the same, just in different lettering. All right, so please try it. All right, so there's not much given here. It says the half-life is 1,600 years. So that has to be your time T. And the decay rate is going to be your rate R. Now, half-life means what? The ending value is half of the initial value, okay? Half of the original. So N of T is going to be half of what you started with, all right? Remember, N sub 0 is the population number at time 0. So this is what you start with, and N of T is half that because we're doing the half-life. All right, so N of T is just half of N sub 0. All right, and that equals N sub 0. We don't have a starting amount, and that's times E to the negative R, which we don't know, times T, which is 1,600. So it's negative R times 1,600. All right, we want to isolate this exponent. This N sub 0 is in the way, but we have it on both sides. So the opposite of times N sub 0 is divided by N sub 0. Okay, it cancels on the right, and it also cancels on the left. We're left with 1/2, and that equals E to the negative 1,600R. E to the negative 1,600R. Now, we can do log on both sides, but since we have an E, we might as well do natural log, because the natural log is log base E. All right, and on this side, natural log of E is gone. We have negative 1,600 times R. The opposite of times negative 1,600 is divided by negative 1,600. Do that to both sides. Cancels here. And R equals this. I'm going to do it on the calculator. And rounding off, I get 0.00043. Okay, this is actually negative, and it's going to be negative divided by negative. That's why this is positive. In terms of percent, if you move it over 2 places, R is approximately 0.043%.